Good afternoon. Welcome to LaRouchePAC Shorts, our regular or semi-regular short feature where we discuss some of the principles and applications of LaRouche's ideas in economics to our current situation. We're joined once again with Brian Lance, who is a longtime associate of Lyndon LaRouche. He's done a lot of economics research. And we've been talking in the last few shorts about the infrastructure project and some ideas about how to get out of the current economic crisis. And Brian's been emphasizing that this has to be done from the standpoint of thinking about the future. And of course, we've witnessed some of the ridiculous ideas coming out of the Biden collective in the recent period, which seems to all be focused on the idea of coming up with a economic policy that's based on sustainability. We talked in the past about the general ideas about technology and so forth. And last week we talked about the space program. And Brian has a lot to say about the energy situation. And what we want to explore today is looking at it from a completely different standpoint than what either the Biden Green New Deal perspective is, or sort of the loyal opposition coming from a lot of the Republicans, and really from the standpoint of optimism versus pessimism. In that regard, I'd like to refer people to the speech that President Trump made at Davos, which is embedded in the article that's up on the LaRouchePAC website by Barbara Boyd called Our Fall Offensive, in which President Trump makes exactly that point, that the doomsayers that we see around the Green New Deal have been predicting collapse forever. And so you have a situation where there's a fundamental assumption that's embedded in the Green New Deal and these kinds of ideas. And what's being lost is, well, what would an energy policy look like that was based not on trying to sustain things on an increasingly decreasing level, increasingly lower level under the guise of so-called sustainability, but actually one which is based on investments in energy production from the standpoint of increasing the productive powers of labor. So Brian's done a lot of research in that area and has some thoughts on it, which I'd like him to review with us right now.
Well, all right, I'll try to be brief. I think, first of all, 2 weeks ago, we briefly talked about reshoring. And I know for some people that's a foreign concept, or they don't know exactly what that refers to. And reshoring is bringing American manufacturing back to the United States. And there's a degree to which that can be done. But as we said then, and this is directly related to energy, is where is that manufacturing going to be located? The grid is now at max, the national grid. That's why we have this continued threat of brownouts and blackouts and all the rest, which the doomsayers themselves, the IPCC and the Greens and so forth, have brought on. So energy, we need 200 gigawatts, just to give an idea. 200 gigawatts, that's 200 big nuclear power plants. But we also, as I'm going to get into a bit, we need natural gas and coal to start with as well. 200 gigawatts would allow us to triple the manufacturing base of the United States, not just based on reshoring, but building up new industries, new supply chains here in the United States that would go into building those nuclear power plants, building those natural gas plants, and of course, from there, moving on to fusion energy.
Well, that's quite an ambitious amount. Now, okay, just so give people a sense of it, how does that compare to, you're talking about 200 gigawatts more energy, correct?
Mm-hmm. Yep.
And how's that compared to, say, what's coming out of these crazy ideas of the Biden and the Green New Deal and so forth? They're not really talking about producing more energy, are they? They're just talking
no.
place. Yeah. They're just talking about replacing existing fossil fuel production with lower density energy forms like wind.
Yeah, digging a hole and filling it in. Yeah, and we come out with nothing added, but subtracted, because we've dumped all of those human resources into the ground, so to speak. In fact, with if you buy into the decarbonization idea, and this idea of literally putting CO2 into the ground, that's what you're doing. You're digging a hole and filling it in. Yeah, quite the opposite is what's required. We have about 1,200 gigawatts of electrical power capacity in the United States right now. And what the Biden collective has proposed is simply to spend well over $1 trillion to build wind and solar to replace existing power plants, coal, natural gas, and since they're not so big on nuclear energy as well, they're going to let the clock run out on that, it looks like. So $1 trillion dumped down the hole, we could build potentially, based on what South Korea does, what China does today, we could build 200 gigawatts of nuclear power for roughly somewhere in around $400-500 billion.
This shouldn't have to take 10, 12 years for each plant like it is right now. If we
right. South Korea builds them in 51 months. The last two plants they built. So that's 4 years and 3 months each.
And they're able to do that with modularization and standardized design and stuff, right?
Yeah, standardization, almost an assembly line approach. You're right, Bruce. Yeah.
So that would actually give us an increase in electrical production, because what the Green New Deal people are talking about is actually the same or less electrical production, but actually increasing the requirements for electrical production, because they're talking about electric vehicles and all this other.
Yeah. Electrical. I'm glad you mentioned that. Electrical vehicles. It's estimated. I'll take a low figure on this. 15 to 20% increase in the power grid to convert the United States to, say, 80% electrical cars. That's to charge the cars. And there's a lot of problems in that. Overloading neighborhood transformers. I mean, it's up and down the line. But just if you take the gross amount, that's if you take 15% increase, I'm just looking for the figure. That's 240 gigawatts, or no, 180 gigawatts for 15%. For 20%, it's 240 gigawatts. So instead of going to tripling manufacturing, you're doing all of that to just dig a sinkhole.
So in order to expand manufacturing, you can't do it without going in the direction you're talking about. You're talking about nuclear, coal, natural gas, and where does the other area of production of fossil fuels come in on this, or how does the coal and
Sure.
fossil fuel? Because Biden's trying to shut that down too.
Yeah. Well, look, this is the CO2 front. Ben Deniston yesterday, that's August 14th for people that might be going to our website later, went through an excellent discussion of this. CO2 has nothing to do with changes in temperature. In fact, changes in temperature sometimes changes CO2. It's the other way around. But you look at coal, clean coal. Clean coal used to be defined as coal to which additives were added, and it took out the oxides, sulfur and nitrogen oxides, and took out the mercury. And there's plants running today, and that's fine, and that's clean coal. But then the game, it was a bait and switch. Then they said, oh no, it's CO2 that's bad. It's not mercury, the oxides, etc. It's CO2. Well, I mean, this is ridiculous. We can, with advanced coal power plants, referred to, if I can find the term here, integrated gasification combined cycle coal plants, which is not unusual these days. Those plants are clean, provide energy, and can be rapidly built. And we have the available coal supply. Natural gas, similar, what's called combined cycle rather, gas plants. In both cases, these advanced plants, both for coal and natural gas, are two stages. And the heat, waste heat out of the first is recycled to boil water and turn a steam engine, a steam turbine, and it produces additional electricity. So this can be done very effectively in a very clean fashion, and we should go ahead and do it because, frankly, starting from scratch, building 200 nuclear power plants, it's going to take a while for us to ramp up. And we need more power to drive the manufacturing, to provide the energy for the supply chain that will then build the nuclear power plants. So it's a step function kind of approach.
Yeah. So the approach you're talking about is actually putting investments into energy production, which actually has an anti-entropic effect of increasing the productivity of the economy and the productivity of labor.
Exactly.
And we have the resources here, the coal, natural gas resources right here in the United States that can be developed, which also is a big boom to the U.S. economy. It's kind of ridiculous that Biden is shutting down fossil fuel production in the United States and then begging OPEC to produce more oil. I mean, there's a big need for fossil fuel production worldwide, and there's a few places which have an ample supply of it: Russia, the Middle East, the United States, and so forth. And it should be directed towards the areas that can actually increase their manufacturing, like what you're describing, which benefits the entire world economy in addition to the United States.
And part of that, as you know, is turning the U.S. into an capital goods exporting nation again. You mentioned modular. We can export modular nuclear power plants. The world's going to need to increase its energy consumption 7-fold, 10-fold to bring it up to U.S. standards and beyond. So we're needed to help do that. That's export market. So we completely reverse our current trade deficits. We manufacture here in the United States, and we reassert our role in the world.
And we need to produce a ton of electricity to do that. We can't.
Absolutely.
Yeah. All right. Now, I want to I think that's a really good perspective, but I want to set the stage for our next discussion, which is the future. These technologies, coal, natural gas, and of course, there's new innovations that can be made in those areas like magnetohydrodynamics and so forth. And nuclear fission, but these are all well-developed technologies. In some cases, they're 100 years old. Nuclear power is 60, 70 years old, is well known. But we're going to need some completely new technologies, which make a qualitative shift. And maybe you could just list some of those things, and then when we get together next time, we can actually get into them in more detail, because the future doesn't end with just 200 megawatts or gigawatts.
Not by
electricity.
This is optimistic, and people should have fun digging into this and making some discoveries for themselves. It's fun. It's fun to sort this business out. Fusion energy. We have the National Academy of Sciences, Engineering, and Medicine. That we can have nuclear fusion power. In their case, they're talking about deuterium, tritium, to the grid starting in 2040, building it by 2035, on the grid by 2040. And they lay out a very specific set of pathways, 4 different teams, 4 different approaches, narrowing it down, a kind of Manhattan project approach to getting it done. But then as well, there's Helion Energy up in Everett, Washington. They're taking a different approach. Very exciting, the Stellator approach, and they're using helium-3 and producing helium-3 as part of that process. Who knows? There's dozens of private projects on fusion. There's the Skunk Works project by Lockheed Martin going on now in Southern California. They have a compact fusion reactor they're working on, which could be online, could be out and available sometime before 2030. They're not making a projection right now, but that's certainly a possibility. And then you have inertial confinement fusion, of course, where you use lasers targeting a pellet. And with the breakthroughs in the chirp lasers that we talked about just for a moment last week, these advanced lasers that in a fraction of a second can deliver enormous power in a very small area, means that the potential for inertial confinement fusion as another approach are within reach. Otherwise, of course, there's the new advanced nuclear sodium reactors, sodium cooled. There's anyway, I'll just leave it at that.
Yeah, that's a big subject, and I'm glad you whet people's appetite for it, because what we have to do is dedicate a whole short to really exploring this, so that people see that, the ambitious program which you outlined in the beginning is really just the stepping stone to build up the U.S. economy, so that we can really kick it into high gear with these really advanced types of science and technology. So thanks a lot for joining us today, and look forward
Good to be here.
to the next short, where we'll take you even further into the future.